This is question number 5. Free response question number 5 on the AP Calculus BC exam given in 2024. This question is actually very straightforward, no tricks in this one. The function f is twice differentiable for all x with f of 0 is equal to 0. Values of f prime, the derivative of f, are given in the table for selected values of x. For x is greater than or equal to 0, the function h is defined by h of x as integral from 0 to x, square root of 1 plus f prime of t squared dt. Find the value of h prime. So show you work that leads to your answer. Okay, so h prime of pi. I don't know if I said that, I just said h prime. So we need h prime of x first. How do we get h prime of x? We want to differentiate this. How do we differentiate this? This should look familiar. We need fundamental theorem of calculus. So we just plug in the upper limit as the variable of integration. So we plug in x wherever there's a t. And then we differentiate x with respect to x. So that would be 1. So times 1, which I did not write. So that's how we get h prime of x by fundamental theorem of calculus. And then we plug in x is equal to pi. So h prime of pi is square root of 1 plus f prime of pi squared. F prime of pi, that's in the table. So it's 6, so square root of 1 plus 6 squared, which is square root of 1 plus 36, which is square root of 37. Okay. Function f is twice, oh, that's the same, I don't know why I'm reading. For what information does integral from 0 to pi square root of 1 plus f prime of x squared dx provide about the graph of f? This should look familiar. This is the arc length. So the integral represents the length of the curve f from x is 0 to x is pi. And you're done. Use Euler's method starting at x is 0 with 2 steps of equal size to approximate f of 2 pi. Show the computations that lead to your answer. Okay, so 2 steps of equal size, they give us the steps actually. But if they didn't give it to us, it'll be from 0 to 2 pi, right? So it'll be 2 pi minus 0 divided by 2, which is pi. So step size of pi. Not a coincidence that they gave us these 2 values. Okay, so we have our initial point, f of 0 is equal to 0. So f of pi is approximately the previous point, f of 0, plus the derivative at the previous point, f prime of 0, times the step size, pi. So f of 0, they give that to us as 0. F prime of 0, that is 5 in the table, so 5 pi. So it'll be 5 pi. Now, f of 2 pi, we do the same thing, the previous point, so 5 pi, plus f prime of pi, that's in the table, that's 6 times pi. So 5 pi plus 6 pi, which is 11 pi. Okay, and then part D, this is all straightforward. It looks a little intimidating, but it's really easy actually. We need to find this integral. Nothing related to this actually. So we just use integration by parts. We see a product of 2 things. You technically could distribute this cosine to the t and the 5, but you would still need integration by parts. So I just tried directly using integration by parts. I thought that would be easier. So if u is t plus 5, du would be dt. dv is whatever is left, so cosine of t over 4 dt. v would be 4 sine of t over 4. Okay? So, I just realized this should be a plus. Let me double check as I explain it again. Okay, so integration by parts is uv minus v du. So it'll be 4 times t plus 5 sine of t over 4, so that's uv, minus v du. It would be 4 sine t over 4 dt. And I move the 4 out because it's constant. Okay, so the integral is equal to, now we just got to evaluate this. It'll be, this stays the same. Integral assigned is negative cosine, so that becomes a plus. And then it's 16 cosine of t over 4 plus c. Okay, so you can even double check real quick that I did the integral part correctly by differentiating. So to get from to here, you should differentiate. So it would be 4 cosine of t over 4 times 1/4. So the 1/4 and the 4 cancel, so we get cosine of t over 4. So that's right. Now from here to here, it'll be 16 negative sine t over 4 times 1/4. So that seems correct as well. Okay. So this is my answers for problem 5. Pretty straightforward, as I was saying.